Hello everyone, my name is Nour Abedrabbo. This is my semester research project about the innovation of waste to energy. Global warming is expected to increase the globe's temperature, which results in adverse effects to human society and the environment. These effects include increased natural disasters, widespread species loss, ecosystem damage, and the flooding of populated human settlements. 40 to 80 million people who live along the coasts of land masses should be forcibly evicted due to flooding, resulting in social and economic devastation. The current consumption and production trends must become sustainable to ensure a productive future. However, it is very unlikely that people will change their lifestyles quickly enough to prevent further harm to the environment. It would be incredibly beneficial for our environment and society if energy were to become created from waste. The main source of pollution to the environment faces that is waste is not handled well. However, waste can be an energy source. Waste to energy is an alternative energy source that condenses energy from produced waste. Further innovations within the clean alternative energy is key to progressing society. Every civilization must maintain waste. Most use landfill sites where waste is burnt, buried, or treated. Leachite is a serious issue where over time some garbage passes dispose under the soil. Harmful chemicals sweep through the soil and contaminate the groundwater. Within the greenhouse effect, about two-thirds of landfills contain biodegradable organic matter, where it decomposes into methane gas, which releases and traps 20 times more heat into the atmosphere compared to carbon dioxide. A waste-to-energy facility contains 5 major steps in its energy conversion process. The reception of waste is where waste is collected locally. Waste storage is where waste is stored in a controlled setting to prevent environmental damage. The incineration of waste is to rid the waste, but produce energy for the steam. The recovery of combusted energy is where energy is collected to use for water heating or electricity. And the energy production is where turbines or boilers use the energy for production. The process begins with the reception of local mixed waste. The waste is collected locally and then transported to the facility and is dumped into a controlled bunker to prevent any environmental harm. The waste is collected with cranes to be relocated into an incineration bunker. The waste incineration begins when the waste travels down a feed hopper and is burned up at about 1100 degrees. The waste energy travels upward at 900 degrees and travels through a large vent at about 650 degrees. Air filtration vents are ready to then cool down the gas at 400 degrees, to then be stored at 200 degrees where straight ash is also collected. This process is the recovery of combustion energy. At the end of the process, the gas energy travels to an electrostatic precipitator. This is a filtration device used to remove any of the remaining fine particles from the flowing gas. The energy production stage begins when the gas begins its cleaning stage, where a filtration bag collects the remaining impurities. Heat recovered from flue gases are contained in a condenser, where acid gases and particulates are cleansed. The heat recovered from the flue gases is then transferred into the district's water heating. After the water heating process, the temperature of the water is 50 degrees. The waste-to-energy process begins when water is pumped through the preheater to the tube walls of the waste-to-energy boiler. At 320 degrees, evaporated steam is conducted from high-pressure cylinders to superheaters where the temperature is increased to 400 degrees. At 400 degrees, steam is conducted from the heater into a heat recovery boiler, where the steam temperature is raised to 535 degrees within a gas turbine. This then leads to the flue gases circulating while heating up the water that is conducted to the district's heating network. However, there are still downfalls for waste-to-energy facilities. Many big businesses are not in support for clean alternative energy as of yet, and are not environmentally responsible. The evaporated steam still may contain harmful chemicals that have not been filtered in the process, and waste-to-energy facilities are expensive. To construct a facility may take around $420 million, and to maintain a facility costs about $220 million per year to operate. Yet, landfill sites are just as expensive. Our society needs more innovative ways in creating energy and managing our waste in our wasteful society. Waste to energy is a mechanism against climate change and promoting a more environmental responsibility. And thank you for listening to my presentation.